morning. Welcome to the Breakfast Club at Carterville Hall in Southborough. I'm Bill Harrington.
And I'm Susan Keir.
And we're here for breakfast. What are we having for breakfast today?
Breakfast, oh, so important. What are we having for breakfast? Well, we have pancakes and sausages and scrambled eggs. And that's all comes together with maple syrup. And for those of you who like something a little healthier, we have fresh fruit bowls and, of course, juice and coffee. I think that just about covers it. Did I leave anything out?
Yeah, you left out the fact that Bill and Elaine Yetman are the resident cooks here, and they're the ones that prepare all this food. And we thank them very much for them doing that each month.
They do a wonderful job, and they come in really early in the morning to make it all happen. So we really owe a lot to them.
We certainly do. They love to do it, too. Who's our guest today, Sue?
Well, today's presentation is one that we have to think about a little bit more. We have Carl Geyer, who's the chairman of the Southborough Green Technology and Recycling Committee. And he's going to give us an overview of the impact of CO2. And don't feel bad if you're saying, what on earth is CO2? That's carbon dioxide, not to be confused with carbon monoxide, right?
Monoxide.
Monoxide, the one that
kills you.
Kills you,
yeah.
Right. So Carl is going to look at the impact of on our planet of CO2. He first looks at the historical data, followed by the impact of current CO2 concentrations. And this is what's causing the problem across the world right now. Finally, he discusses how we can make changes and change the impact on our environment of CO2.
From a local level.
Right.
At a local level.
We're going to focus on Southborough and what we can do here in town, and how we can stop the current warm-up of our planet. So lots to think about, Bill.
Certainly is. Yeah, I understand that for hundreds of years the parts per million ranged around 150 parts per million, and now it's spiking up towards 400, thus the name of his little talk called 400 and
Rising.
Rising, right.
And it's an interesting fact that I know a lot of people say, oh, but this has been happening throughout history. There was the dinosaur age and the ice age when they all were wiped out because of climate change. Well, the fact that Carl explained to me is that it took thousands and thousands of years for that to happen. But the recent spike in climate change has taken place over the last 200 years. So that's a big difference.
That's phenomenal.
Unfortunately, the USA is one of the biggest contributors to the problem. We have to own up to this. We love our big cars and all the other manufacturing and all the other things that contribute.
I always thought China was the biggest offender.
Well, I think we all have our part to play in this.
So, why don't we go over and see Carl and see what he's got to talk about this morning over at the function hall.
Yeah, my name is Carl Geyer. I'm on the Green Technology and Recycling Committee here in town. We're in what's called an ad hoc committee, right? We're appointed by the selectmen, right? For years, we were just the recycling committee here in town, and we got a promotion a few years ago. Now we're the Green Technology. We're doing such a great job, right? So we got promoted. So now we're the Green Technology and Recycling Committee. And I have to introduce one of our other members. Many of you probably know him, Stan Tenenholtz over there. Stan has been on the recycling committee for no, he's not going to sing. Yeah. No. Stan's, no. Yeah. Stan has been part of the recycling committee for, I don't know how many years, Stan? Do you know?
My memory isn't that good.
All right. Yep. All right. So,
From the beginning.
yeah, I did this presentation, a few months ago at the library, right? And the reason we're doing this is we're trying to raise awareness in Southborough about the need for Southborough to adopt more green programs to try to become a more green community, right? And I'm actually going to talk about that at the end, what we can do, right? But in order to get people motivated, right, I want to give you some background as to why so many people are concerned about rising CO2 levels and what it's doing to the environment. And I present a lot of data, right? So you never see this on the news. They just come on and they say global warming's happening. You hear people talking about, like the president talking about it, prime ministers talking about it. You know, a lot of people talk about this, but they don't explain why they think it's important. So I'm going to kind of go through why they think it's important. Now, whether you agree or not is up to you. That's your thing. So first question I have to ask, I'm going to talk about climate change. Does anybody have any idea what that number 400 has to do with this? Anybody? Yeah, Stan does, right? Okay, we'll get to that, right, in a minute. But that's an important number, right? And it's rising, right? So let's move along. Yeah, hopefully we'll move along. Come on. Here we go. All right. Since the 1950s, right, they've been measuring the content of CO2 in the atmosphere. Everybody, carbon dioxide, right? Everybody knows it's one carbon atom, two oxygen atoms, right? We breathe it out, right, all the time, right? And it's been steadily increasing, right? And this is a graph that shows the measurements that's been made. Now, this is from a mountaintop up in Hawaii, right? Measuring this is a great job if you can get it, right? So as you can see, the graph shows a continually increasing level, right? Before I just want to talk about what the scales are here. Down below, you see the years. You know, they started in '59 measuring it. And then not only do they measure it here, but it's about 5 other places in the world that they get about the same measurement, right? And the reason they use Hawaii is because they're not downwind of anything, right? The air is moving across the Pacific. There's a lot of mixture. You know, you get a real good average of what's going on, right? You wouldn't want to do this downwind of Chicago because it would be going all over the place, right? So down below is the years, right? Starting in '59 and up to the present time. And then on the vertical scale, it's parts per million. Now, I don't know if you realize this, but there's very little CO2 in the atmosphere. When we're talking about the amount, we're talking about levels of 200, 300, 400 parts per million, right? It's a very small amount. To relate to this, think of it in terms of money, right? If you had $1 million, you'd have a lot, right? How much is $400 out of $1 million? Very, very little, right? But it's very important. CO2 is so important. I mean, actually, you provided your breakfast this morning, right? Because all of your breakfast this morning came from atmospheric CO2 because you're eating plants and animals, right? And all that carbon that you just consumed came from out of the atmosphere. Plants are amazing. I mean, such a low concentration of CO2, they're able to grow, right, and extract enough nutrients out of the air to provide you with food. Actually, all the carbon in you, right, is from the air, right? So even though it's such a low concentration, it's very important to life. As a matter of fact, if you get down below 200 parts per million of CO2, all the plants start to die. They literally starve to death, right? So the good news is we're going up. Bad news would be really bad if we were going down, right? Because if we were extracting CO2 out of the atmosphere, it would be an absolute disaster, right? So you can see, it's the scale. It starts at 230 and goes up to 400, right? So you can see when they started in about 1959, it was like 320 parts per million is what they were measuring, right? And then it's going up, right? There's a lot of information in this graph, right? One is that you can see the graph is trending the curve up faster, right? The level of CO2 is rising faster. It's not linear. It's not going up in a linear fashion. This is because of all the industrialization in the world, right? Right? So it's curving up. And then there's also, in the red, is the actual measurement. The black line is kind of like the average, right? The red line is seasonal because if you look at the globe, if you ever take a globe and flip it over and you look at Antarctica, look at it from the Antarctica perspective, it looks like water world. There's not a lot of land on the southern hemisphere, right? You flip it over and you look at it from the Arctic, there's a lot of land. So what you're looking at is spring and winter in the northern hemisphere, right? The CO2 level actually drops every spring and it goes back up again during the winter, right? In the spring and summer, it's going down. All the plants they stop growing at the end of the fall, and then the CO2 level keeps going up, right? So that's what that sawtooth is, right? The other thing about that, and you can't see this in the sawtooth, but that sawtooth is getting bigger every year. And I'll explain why. But if you look at the actual, it's too small of a change to see in this graph. But every year, that's getting bigger. Right? And there's a reason for that, right? So you can see it's going up on a regular basis. Now, the 400 in May of 2013, right? Because May is at the end of the winter time when the CO2 levels are the highest. For just a couple of days last year, we hit 400. That was a big deal. Right? We got up to 400, right? And a matter of fact, I just checked this morning, right? Because I knew I was coming here to see where we were. And just 2 days ago, here we are in March, right? On this sawtooth, we just hit 400. So it came earlier this year. So that's just another indication that the level keeps going up and up and up and up and up, right? And I'll actually show you the rates, right? So the level of CO2 is going up all the time, right? And because the two main things that are important in CO2, one, it's an insulator for radiation leaving the Earth, and we'll talk about that later. And it's also very important for life, right? So it's a very, very important chemical. It is a chemical, right? In the atmosphere that we depend on, right? Now, to look back in history to see where CO2 levels have been over history, right, way back, right, you can go into what they call ice core data up in Greenland, right? The ice is very thick in Greenland, and they bore down into the ice and they take a piece of ice out, right? And inside that ice is air trapped inside there, right? And that air represents what the condition of the atmosphere was at the time the ice was formed, right? So if you melt it, right, you get the atmosphere, the components of the atmosphere at that time. So here's a graph. This gives you an idea what's causing all this rise in CO2. You can see back in the year 1000, right? And it traveled along 1600s, 1800s. All of a sudden, the CO2, that's again parts per million over the side over there. Parts per million, Industrial Revolution, right? We started taking coal out of the ground. England discovered how to build steam engines, right? Started taking coal out of the air, and the Industrial Revolution kicked in, and it's just spiked, right? It's just going up like crazy now. Right? Now, we go back even further. Oh, fun thing I forgot to mention. You can see 280 is about was what people call the natural background level. That's where it's been historically. 280 parts per million. We're up to 400. Right? That's a pretty large change, right? So we're up. We're going up.
Can I ask a question?
Oh, sure, anytime. Yeah.
How come it went down in 1600?
I don't know. I honestly, I have no idea. I know there was there's natural variation to this, right? And I know sometime around there was this thing called the Little Ice Age, right? I don't even know if that's the cause of it. I have no idea, right? But it does. It varied as it went along. Matter of fact, as I say, great question, because here's the next graph. The ice core data up in Greenland is so thick, they can go back, I left the zero out, 80,000 years, right? They're supposed to be 800,000 years, right? Right? I left a zero out there. I just realized that after looking at this for so long. All right, so here we go back 800,000 years, right? We're talking about going across ice ages, right? Greenland's been collecting ice for years and, a long time, right? Same idea. You bore into the ice. The ice is like 2 miles thick up in Greenland. You bore into the ice. You get a sample. They can carbon date it. You guys probably heard about carbon dating, just by telling it has to do with carbon-14, the ratio of it. I read an article how it works one time. I can't explain it now, right? So it goes back 800,000 years, and you can see the CO2 level has been jumping up and down for quite a while. I mean, it's just natural change, right? Ice ages came along. There were ice. The Earth was covered with ice. The plants were gone. So you can see it's been going up and down. But here we come, the Industrial Revolution, and we're spiking it. We're up higher than it's ever been for a long, long time. Matter of fact, the next slide deals with that. So we have really made a big change, you know, in the levels. And this is the kind of information that people are looking at, and they're saying, you know, what's this going to do, you know? And this is my own invention, but if you want to think of what we've done, right, in terms of time frame, because we're only talking a couple hundred years, that we've really altered the amount of CO2 in the atmosphere. I call it an instantaneous geological event, right? Because geological events cover millions of years, right? So 200 years is nothing, right? So it's like we've been hit with a asteroid, right? There's something that's crashed into the Earth, and usually when things like this happen, this much change, this fast, it's usually not good for life on Earth. I mean, I don't think life is going to go away, right? But it's change, right? And we're just beginning to see the impact of it. All right, so what caused all this CO2? Where did it all come from? You know, I think probably most of you already know this, right? But this graphically represents it. It's our appetite for energy, right? Fossil fuels. Fossil fuels are carbon fuels, right? It's all carbon, coal, gasoline, diesel, you know, methane, propane. That's all carbon-based, right? And we're essentially we're pulling all this stuff out of the ground that's been in the ground for millions and millions of years, and we're releasing it as CO2 into the atmosphere, right? This stuff has been trapped for millions of years in the ground, right? And you can see nuclear power adds some. The stuff called renewables, right? It's added a little bit to our energy appetite, but we're really fossil fuel dependent, right? As a matter of fact, it's not really a joke, but it's kind of an example that you think of the kids over at Neary School, right? And because we're up to 400 parts per million, and the natural is kind of like 280, 250, about 1/3 of all the get my picture taken here. 1/3 of all the CO2 in the atmosphere has come from fossil fuels right now. So the carbon dioxide that's floating around in this room right now, about 1/3 of it was, the carbon part of it was in the ground as fossil fuels, right? Coal, oil, you name it, right? So you're a cabbage growing out in a field, right? Think of yourself as a cabbage, right? You take in CO2, and you take water from the air, right? That's where you get it from, the air, and you take water from the ground, and you grow, right? So 1/3 of all the carbon in a cabbage that's growing out in a field these days, trees, you name it, whatever you want to think about, 1/3 of it, that carbon came from fossil fuels. That's not bad. I mean, it doesn't matter where the carbon came from, but 1/3 of it. So our kids are now eat all this stuff, right? Now, this is not harmful. It's just an example how pervasive this is. About 1/3 of all the carbon that makes these kids up over at Neary School came from fossil fuels now. It's not bad. It's not good. It just shows how pervasive, how much we're changing things, right? So, move on. I don't know if that was a good example or not. If it got anybody's attention, but it's in. All right. So, projections for fossil fuel reserves guarantee we're going to produce CO2 for many years to come, right? There's a ton of this stuff left. Crude oil. Now, this number may even be low because of all the fracking that's going on. You guys know about fracking, right? They found new methods to get even more of it out of the ground. You know, another 52 years at least, right? Natural gas, another 55 years, and probably higher. Coal, another 135 years. I mean, that curve is going to keep going up, right? It's going to keep going up. Hard coal, you know, another 114 years. This is the stuff that they call, that they're getting out of the ground. Lignite is the stuff, it's up in Alberta, Canada. This is tar sands, they call it. There's a lot of names for it. They extract it out of the ground, and then they use steam to get the hydrocarbons out of the air. This is a huge thing going on up in Alberta, Canada. Keystone Pipeline, you guys heard of the Keystone Pipeline? That's what that's all about, trying to get that oil from there down to down to Houston, right? So we're going to drive this curve for quite a while if we keep going. So we're going to go 400, 500, 600. We're just going to drive it right up if we keep going at the rate we're going, right? There's a little note on the bottom. It's good news for us. Price of oil is going to be down. Short-term economics is cool, right? We're going to be all right. And our lifestyle isn't going. Our immediate lifestyle isn't going to get affected. Right? There were a lot of people thought we were going to run out of oil for a long time, right? Okay, so why all the attention to CO2 levels? What's the big deal? This is a quote. I don't know if you know who. How many of you know what the IMF is? Ever heard of the IMF, the International Monetary Fund? Right? You've probably seen her on TV, Christine Lagarde. She's the new head of she's a tall, very stately-looking woman who is now in charge of the IMF. She just took over about a year ago. Right? Now, the people at the IMF don't say things. It's like Ben Bernanke. I mean, he doesn't come out and say things willy-nilly, right? Because it has a big impact. This is a statement this is an official statement that they made. The International Monetary Fund. These are a bunch of bankers, right? Her statement is pretty sobering. It says, and it actually says that. It says, the science is sobering. The global temperature in 2012 was among the hottest since records began in 1880. Make no mistake, without concerned action, the very future of our planet is in peril. Maybe a little bit of an overstatement, but that she's driving a point here, right? And they don't make statements like this without a lot of thought, right? So this is the IMF is behind this. Most large government organizations have come to realize, because they get information, they get this kind of information, probably much better than what I'm presenting, right, to them. And it seems like when people are exposed to this, they become convinced, right? Okay, now we're at 400. The last time, and this is very hard to tell because there's no ice core data to go back 15 million years, right? And it's somewhat hard to determine, but there's been a lot of work done out at Stanford University trying to determine what CO2 levels were in the past, right? And they put out a study a few years ago, and they figured last time we were at 400, right? And we're going past 400. We're just going to zoom right by it very soon, right? It was 15 million years ago. That's a long time, right? Things were very different, right? And as a matter of fact, the next statement says that, when they were this high, and they stayed that high, right? CO2 doesn't go away very easily, right? The global temperature was about 5 to 10 degrees warmer. That's a huge impact, right? And sea levels are approximately, 75 to 120 feet higher. Right? We're okay in Southborough. I checked the elevation. We're at 300, right? So you guys won't have beach property, right? So, and there was no permanent ice cap in the Arctic, and we're going to talk about that later because the Arctic's been melting, and there was very little ice on Antarctica and Greenland, right? I don't know if you know, but sea level rise, there's two components to sea level rise, right? The first one is just all this ice melting going into the ocean, right? That obviously, the Arctic melting has no effect because it's floating, right? But like Greenland, Antarctica, all the glaciers and all that, those melting raise the sea level. The other one that raises the sea level that most people don't realize is just warming up the ocean, and the ocean is warming, right? Warming it up, water, like most other substances, when you warm it up, it gets bigger, right? So, and the ocean can't go down. It's not going to go down, and it's not going to go sideways, so it comes up, right? So a good portion of the sea level rise is not just from new water introduced to the ocean, it's just from the ocean warming up. Right? Now, we've already raised the temperature of the air in the last 100 years. And it's going to take a long time for the sea to warm up, but we're going to see continual sea rise coming up, and that's going to endanger a lot of properties on the coast. But that's what's going on. Hopefully that makes sense. Does that make sense to everybody about sea level rise? Right? I'm just loaded with good news, aren't I? All right. So, there's also a historic link between global temperatures, CO2 levels, and CO2 levels and sea level. And this is just over the last, 500,000 years, right, where things have gone. Now this, you can see temperatures go up and down. Those are ice ages, right? And they have names. You can see they geologists give them names. We're in the Holocene, I can never keep up with these, but they give them names for different eras, right? And those peaks and valleys are the valleys where it's temperature of those ice ages, right? CO concentrations, it kind of follows the ice ages. And then sea levels go up and down, right? And we're currently on a rise here. But you notice, we've really kind of dumped over the apple cart here. We've driven CO2 out of sight. So it's out of sync, totally out of sync with what has been naturally happening, right? So we've really juiced the CO2 level, right? There's a guy who's 1/3 fossil fuel, right? He's probably, what the heck is he talking about, right? So here's just a little basic primer on how global warming actually works, right? Hopefully this won't be we'll go through this easily. Okay, the sun's energy, when it comes to the Earth, right, it comes it's called electromagnetic radiation, right? It's not conducted, right? It's radiated, right? Difference between conduction and radiation. Like conduction is when heat travels through a solid, right? It's radiated, right? Because the sun's really hot and we get radiation, right? And it comes to us in different wavelengths. Have you ever seen this? It's the spectrum. The sun generates, it's a vicious thing. It generates all kinds of radiation, all the way from X-rays, and gamma rays, ultraviolet, visible light. You all know visible light comes from the sun. Then there's infrared, which transfers heat. Right? It's a heat. We associate that with transferring heat, right? Because we're so. And then there's thermal infrared, and there's microwave, and there's TV and radio. All that stuff is coming at us from the sun, right? All the time, right? So that hits the Earth every day, right now, outside. It's all plowing into us, and it all comes in that array of formats. So there's the sun. Let's see if this works. Here comes all this electromagnetic radiation, And a little note below there says if all this energy, and it's energy, right, came plowing into the Earth and couldn't get out, right, we just get warmer and warmer and warmer and warmer. That just makes sense. It's like a pot of water sitting on top of the stove, right? You just keep heating it up. It just gets hotter and hotter and hotter, right? But it doesn't, right? It leaves, right? All this energy that comes into us during what we call the daytime, right? It's always going on because there's always daytime and there's always nighttime, right? All this energy that keeps plowing into the Earth, right? We come around, we get warmed up, and then we go around the backside. It's dark, right? And then you've heard of radiational cooling before? That's what happens. All the same amount of energy that came plowing into us from the sun gets radiated back out to the outer space as infrared, right? Only part of the spectrum. We don't send out gamma rays. We don't send out visible light. We don't send out X-rays. We don't send out radio waves other than our radios, antennas that are running, right? Little things. But all that energy leaves as infrared, going out of the backside, the dark side of the Earth, right? So every night we cool down because of radiational cooling. We come around again and we pick up another, batch of energy, right? Temperature goes up, we go around the back, we cool down again because of radiational cooling, right? Because that cycle keeps going on. And there's a huge amount of energy involved in this, right? Okay, you wrap the Earth with a little bit of insulation, which CO2 is. To infrared, right? CO2 is like a brick wall. Now, you can see through the windows. Those windows are solid, right? You can see right through them. The windows are transparent to visible light, right? You can't see through the wall, right? For CO2, for infrared, CO2 is like the wall. It traps it. Right? And there are different. I used to work for Raytheon. Right? Used to work on designing what they call the radomes on the front of the missiles. Right? And there's radar inside of there. Those are ceramic. They work on radar. Those ceramic domes were invisible to radar. They could see right through it. You can't see through it. It's visible. Light can't get through it. But because of the characteristics of those components, radar goes right through that like it's a window. Right? So those ceramic fronts of missiles, for radar, it's like a window. Right? The same thing with CO2. CO2 is like a brick wall to infrared. So if you put a little bit, and so it acts like insulation. So you put just a little bit of insulation, the temperature goes up. Because if you put a little bit of insulation, and the temperature has to go up in order to radiate, because radiation works on the higher the temperature, the more radiation you get. So the temperature goes up in order to radiate that same amount of energy, because we've got to come back in balance. You put a little bit of insulation in, we've got to warm up in order to get rid of that energy. Right? So that's essentially what's going on. Now here's another graphic. Maybe I shouldn't have put this in here, but I gave a very simplified version of it. But actually, between the atmosphere and the Earth, there's a lot of interaction going on. The energy gets trapped in some of the atmosphere, some in the clouds, some in the Earth's surface, just gets bounced off, and some gets absorbed by the land, and then going out, it goes out in different formats. It's more complex than the simplified version I just showed you, right? But it's still basically the same idea, right? What's been the impact so far? I don't know if you've seen this graph, right? This is a plot of the Earth, actually measured. I mean, this is measured. This is not speculation, because these actually come from measurements, right? From 1900 all the way to the present time of the Earth's the atmospheric temperature. What's been going on, right? So you can see there's been a general increase. Now, it goes up and down a little bit. There's natural variations. Things happen. There's variations in the sun output. Volcanoes go off. A lot of stuff happens, right? But the general thing is there's definitely an increase. We've gone up, I think it's almost a degree since the 1990. That's a big deal. I mean, because the average temperature of the Earth is around, I think it's 60 degrees?
60.
Oh, okay, good. It's around 60, right? So it's gone up a degree. That's a big deal, right? Now, there's a lot of global warming skeptics in the world, right? And one of the things they like to point out is, you see how it's kind of flat at the end here? You will hear people you'll see them come on TV. They'll say, there's been no global warming for the past 10 years. You'll hear them say that. Well, it's been warm for the last 10 years, right? It has not dropped down. If they have no global warming, would mean whew, it came down. We came down, like there's some kind of natural cycle. That hasn't happened, And this spike that happened back, I think it's 1998, that spike, there's this thing called, you've probably heard of it, called El Nino, right? Where the Pacific warms up. It's a cyclic thing that goes on, right? There are El Nino events, and they have a big impact on the Earth's atmospheric conditions, right? So those little spikes, each time an El Nino happens, right? And so they kind of like juice it every once in a while. They juice it up, and then the temperature kind of climbs, and it drops afterwards, because there's this opposite effect called La Nina, which is what we're doing right now, that's going on now, that cools the Earth down. We're in a cooling period right now, but the temperature's coming up. Now, here's a little thing. January, we've had this wickedly cold January, right? This January was the fourth warmest January on record for the Earth. There are only 2 areas in the globe, and if you go home, you guys got Google, go home and Google it, temperatures for January 2004 global temperatures. You'll get a map, that shows that, in the Northeast, in this region, and a part of, I was going to put it in here, but I didn't get around to it. And part of Siberia, northern Siberia, have experienced unusually cold weather, but isolated. The rest of the Earth has been seen above average temperatures, and a lot of record temperatures too, right? So, so this January, even though we were freezing, right, and we had the Arctic vortex, they called it, right? We were experiencing this, right? Alaska was, my joke, baking, right? And the Antarctic was up about 5 degrees. I'm sorry, not the Antarctic, the Arctic was up about 5 degrees. So, and this is a graph that shows global temperatures with respect to these La Nina and El Nino events, right? Remember, La Nina is a warming event, a natural warming event that happens on a regular basis, and La Nina is a natural cooling event. So you can see, that it may be hard to see, but over on the vertical chart is degrees Celsius, variation from average, right? So you can see back in the, when does this start? Back in the 50s, you can see those two different effects. Actually, when the warming one happened, we were above average. When the cold event happened, we were below average, right? And then as we've progressed along, even the cold events now, the blue ones, right, substantially above average, right? So even when we're supposed to be dropping below average through natural cycles, we're much above. We're, as I say, half a degree above what we normally see, right? And that trend is just continuing on. Oops, didn't want that. Nobody going home and shooting themselves after this, please. I don't want any suicides. All right, so here's another plot, right? This is what's going on up in the Arctic, right? You've probably heard about the Arctic melting, right? You probably heard it on the news. This is a graph, and it's a little complex, but I'll explain it, right? Each one of those bands is a different month during the year, right? And what this shows you is the amount of area that's ice, right? So the ones at the top are obviously winter, right? So because there's more ice up there in the wintertime, that makes sense. And then the one down at the bottom is, I think, is July or August or something like that in the summertime, right? And then the line, the continuous line is kind of a trend, but the actual zigzag lines are measurements, right? So you can see, and this graph actually goes, it's very hard to see, right? It actually goes down to 0 at the bottom, right? This is not, sometimes people play with graphs like this where they change the scale, so you only see a part of the thing and it exaggerates, right? This is not an exaggeration. The scale goes down, right? And you can see that the general trend is, in the summertime, this is pretty well, people are planning on this now. In the summertime, it looks like we're headed for an ice-free Arctic. As my other, I don't have good jokes, but I use them anyways. I just say, I hope Santa Claus has red swimming trunks, right? Because he's going to have to tread water for a while, right? Who's that kid? Did he leave? What can we expect in the future? As you can see, the rate of increase is going up, right? The graph showed that, and this is just numerically. 63, 72, we're going up less than 1 part per million per year. We're going up over 2 in the last 10 years. And currently, in the last couple of years, we've gone up at like 2.5. I mean, the world is becoming more industrialized, right? So it's just accelerating, right? All right, I won't spend a lot of time on this, but this is just, people have models. I mean, it's very difficult to predict, right? But people are predicting what the temperature changes are going to look like, and it's no surprise. They're all predicting it's going to go up, right? The temperature's going to go up with time, right? And it just depends. The question here is, how much is it going to go up, right? There are a lot of different models saying it's going up. But even a 2 or 3 degree rise is a dramatic effect, on the Earth, because it'll shift. That's what they call climate change. If the temperatures change that much, the climates will shift. We'll become more like Georgia, right? And then Georgia will become more like Mexico, and things and precipitation patterns will change. I mean, these are all good efforts to try to predict stuff, but it's very, very hard to tell what's going to happen. It probably won't be good. All right. Now, there are some people who say this is great, this is good stuff, right? There's you can find this. There's a website out here that says, remember I said CO2 levels going up? Plants love this, right? This you probably can't read it, but what it shows over here is that if the level goes up 300 parts per million, we've already gone up 150. We're going to be at 200 very closely. You can test this. This is just something they can test. They put plants in an environment with an elevated CO2 and watch them grow, right? There's a list here on this website that says, this is going to be great. Food's going to grow like crazy, right? We're going to be growing a lot more food. We're going to get more food per acre because of the higher concentration in CO2. So it's not all bad news, right? But I think that's kind of a rosy prediction because, number one, that's going to cause some species are going to like this better than others. So you're going to get different compositions in the plants that grow in an area. The insects are going to love it. There's more food for the insects, right? Yeah, we'll grow more food, but other things are going to happen. So there's the website if you want to go to it, plantsneedco2.org, right? You can check them out, right? And down there, the guy holding up the signs, he says, okay, over here, here's what ambient, CO2. If you increase it 150, I don't know if you can see it, that's how much bigger that tree grew in the same amount of time, right? And then if you increase it 300, that's how much bigger the tree grew. And if you go up 450, it gets a lot bigger. So you can see plants are loving it. And I mentioned that the spike was going up and down at the beginning, that sawtooth, right? That sawtooth is getting bigger because the Earth is actually getting greener. There is more plants growing now than there were in the past because of all the CO2, right? It's food, it's better than fertilizer. Fertilizer just provides it with enzymes and catalysts, right? CO2 is the food. It's just for plants. So they really like it.
But the problem is the weather's changing too.
Well, yes, the weather is. Yeah.
It's in a greenhouse, but in California, where they're having a dry spell,
right,
and it's very hot, where we get most of our food from, it ain't growing so much.
Yeah. I try not to link specific things to global because it's like 1,000-year storms. How often should you see a 1,000-year storm? Sandy was a 1,000-year storm, right? How often should you see those? Once every 1,000 years. If you see 2 of those in a row, what's the possibility of that happening? 1 in a million. Right? So if that happens, then you've got a new norm, right? The norm has changed, right? The probability has changed. So you've got a new norm, right? That's what's going on, is the norm has changed. So to answer your question, what can we do locally, right? Act locally, right? There's one thing that we're advocating, and we've got one of the selectmen convinced that this is a good idea, right? Maybe we can get 2 or 3 of them convinced, right? There's going to be more elected soon. Maybe it'll be easier to convince the majority, right? There's this thing that we were advocating a little while ago called the Green Communities Grant Program. It's a program set up by the state. I mean, it's not going to solve global warming, but it's a step in the right direction, right? Where the community makes some changes to try to make the community a little bit more green, kind of reduce fossil fuel consumption, that kind of thing. One thing we've been advocating. Oh, did you have a question? Well, I'm not going to go through what cost. I'll tell you what the details are, though, right? I can explain that, and I can answer some questions about that. Yeah, well, it's our little town, right? So Green Communities Program is a good idea, right? We didn't do it this year, but we've done it for the last couple of years. We show up at the transfer station. We're handing out information about mass energy audits. I don't know if any of you have ever done this. There's a Mass Save. You can find them on the web. You call them up. They'll come out, they'll do an energy audit on your house. They won't charge you for it. I say to people, you've already paid for this, right? Because those little items on your electric bill that, the hundredths of a cent per kilowatt hour, right? That's where the money comes from. So you've paid for this. You call them up, they'll come out, they'll do an energy audit. A lot of people had a lot of good success out of this. They'll find problems with, if you have problems, they'll find them, right? And you don't have to do anything about it if you don't want, right? But most of the time, the things they will, the save is save money, right? So they'll find places where you're losing energy. Maybe you've got poor insulation someplace. Maybe there's a lot of air infiltration, they call it. They can test for air infiltration. That's a big loss of energy. You know, wind just blows right through your house. You don't even know it, right? We like to get some more community awareness programs, which is exactly what I'm doing here, right? And then we'd like to get some new recycling programs going. But let me talk about the green communities thing for a minute, and we can. There are now, it's over 110 communities in Massachusetts. This is from last year. They've added another 6 or 7 communities. Right? It's called a grant program because if you qualify for it, the town can apply for grants for energy-saving projects. Right? Like maybe this building hasn't got that great insulation in it. Right? If we become a green community, the state will give us money to help insulate it better. That's generally what the idea is, right? And there's probably close to 120 communities now in Massachusetts that are now designated as green communities. And once you become designated as a green community, you can apply for the grant money. You can't apply for the grant money if you're not a green community, right? You're locked out, right? How do you get qualified as a green community? There's 5 steps. One is the first 2 are zoning law changes, right? Have to go before the town meeting, right? One is called as of right siting, right? For renewable energy and alternative energy companies. What that says is that if you're a company engaged in either renewable or alternative energy business, right? The town writes into its bylaws. We have this, like we say for office parks and certain things like that. We say we want that kind of industry here. So when you come in, it's not like if you came in and you say, I want to put an oil refinery in Southborough. Well, our bylaws will probably stop you from doing that, right? This will give you the right to be here, as opposed to I'm asking to be here. You have the right. It's a different approach, right?
Wait a minute.
Wait a minute. Go ahead.
If this is alternative energy and renewable energy, that would not be an oil refinery.
No, we wouldn't allow, you still wouldn't allow oil refineries in. They don't qualify as renewable or alternative energy. I just used that as a bad example. Maybe I spoke too quickly.
So it would be like Westboro with their solar, and actually the one over here, the solar
Right.
display of
Right.
array, the thing
Right.
there.
We would be encouraging more of that in the town, right? Now, the other thing they want you to do is because towns like Southborough have a way of clogging things up, right? I'm part of it. I'm on the Conservation Commission, right? I'm part of the clog, right? There's this thing called expedited permitting. So you give the as of right siting for certain. You don't have to do the whole town. You can pick just certain areas even of your industrial and commercial areas. You don't have to pick all of it. You can just pick some of it, right? You can't make it like an acre, right? They won't allow you to do that, right? And qualify. But you got to do something reasonable, right? So, and then you also have to, in that area, you have to implement expedited permitting, which says the town puts itself on a schedule. If you come in and you want to say you want to build a new building to put in you want to manufacture solar panels, as an example, right? You come in, you put your application in, there's a schedule that the town follows and to get that done, right? It's predictable, it's known. I mean, the applicant can slow it up by not doing the right things, right? But the town will respond in a certain amount of time and it's a schedule. The one thing that people might get concerned with this is that expediting permitting would not just apply to the renewable energy part of it, but in that area, it would apply to all permits that go in, right? So that's a little bit of a rub to some people, because even if you came in and you wanted to put a McDonald's in, let's say, you would fall into the expedited, if it's allowed, you would fall into the expedited permitting process, right? So,
Well, if it's allowed
just
to
let
be
you.
with, then it ought to be expedited.
Yeah, right. I don't disagree with you. Right? Now, the other thing that they want you to do, and this is to establish a plan to reduce the energy consumption for municipal buildings, right, by 20% in 5 years. Now, it's a plan. All they ask is you put a plan in place, right, a reasonable plan, right? And the way this works is you get certified with a plan, right? And then as time goes along, If you completely blow it and you don't even come close, you lose your certification, right? But if you put a good faith effort in to try to get that down, you can maintain your certification, right? So, and they review that, they look at how well you're doing, you know, and see if, you know, if you're actually following your plan, right? So that can only save the town money, right?
Do they, once you get this plan in place and it's been certified, can you use grant money to implement?
That's exactly what you do.
Okay.
That's what you do, is you apply for grant money to get some of this stuff done, right? And it's the grant, you get an initial $100,000 to $150,000 for getting certified. That's what they've been doing at first, in the first go-around. You get certified, they give you a grant right away. After that, our facilities managers, and I talked to them, what they'd have to do is they'd have to come up with a plan for some kind of project, and then they would put that into a pool of other plans from other towns, and then they look at the list, and they say, okay, which are the best ones, and they award to those. Yeah, that makes sense, right? Best plans should get certified, you know, get money. You know, bad plans should not get, you know, right? The next one is purchase certified fuel-efficient vehicles, right? I think there's only 3 vehicles in town that qualify for this, right? Maybe even less, right? It excludes emergency vehicles. It excludes heavy equipment, like, you know, the front-end loader that the town has. And all those, the heavy equipment is not included, right? So there's only like 3 vehicles. So all the town promises that they'll buy fuel-efficient, and it doesn't make them, it doesn't force them to buy hybrids. All it does is ask them to buy something with reasonable miles per gallon, right? It's not a tough one. And then the last one is another one. It's like the first 2 can, you know, they call it, it's a nice name, minimize life cycle costs. It has to do with homes. There are 2 standards that the state uses for building codes. They call it the standard building codes, which every town has to use, right? Then they call them the stretch codes, right? And they reissue codes every 3 to 5 years. I don't think there's any set schedule, but typically what happens is they set the standard codes, and then they set stretch codes, meaning, you know, they're more of an effort, right? They're kind of futuristic. They set those out there as kind of an experiment, right? And they look at what happens with those, and then usually what they'll do is they'll take that stretch code and they'll bring it down to the standard code the next go around. So the stretch codes usually roll down to the standard codes every cycle, every 3 to 5 years. So what was the stretch code becomes the standard, right? The standard gets upgraded. There's a new stretch code. They go further out, right? They try to make the code even more stringent, right? So what this asks the town to do is to adopt the stretch codes for energy-related features on homes. Now, I sat down and I talked to a couple of the large builders in town. They're not too happy about this, you know, because it adds cost to the home, right? And they're competitive, right? But there are 110, 120 communities in Massachusetts that have done this, right? And because it really does, they're fairly well proven that if you do these things, that, you know, they tell me, hey, Carl, people want the granite countertops before they want the fancy furnace, right? That's exactly what they say, you know. They'd rather spend the money on a countertop than the furnace, right? So, and this last one is this is coming to the end here. If this were only true, right? If we just get, you know, if it turns out to be a big bust, and it really snows more than it has in the past, and it gets colder, you know, if everything turns down, okay. So the worst thing we do is we save money on fuel. We don't spend as much money on fuel, right? That's why. And the green communities thing, it's just, most of those things are just going to help save money, right? They're not bad ideas, right? So, and that's it, I think. Yep.
Okay, Bill, so what did you think? That was a lot of information, wasn't it?
There was a ton of information. Some of those charts were quite interesting. It showed how the CO2 has spiked in the last couple hundred years. That's an amazing thing, something to really be concerned about, something we need to be thinking about, and what can we do here at a local level to help solve this issue?
Well, that's true. There are things we can do at a local level. And things we can do here in Southborough, and I know it seems in the big scheme of things, this is really going to make a difference. But I guess you have to start somewhere. So some of the things Carl talked about I thought were good. Mm-hmm. Recycling, which is something we can all take part in. And, you know, one of the big things are cars. And I'm guilty of this as much as anybody else. We love to drive those SUVs and have lots of space. We love to drive our cars everywhere. But they contribute tremendously to this problem, using all that gas. Mm-hmm. So smaller cars. Europe is doing it. They're way ahead of us. And we need to follow that trend. Another thing which we could actually do here in Southborough, look at our municipal buildings. How we're using the services and the fuel to run them. Mm-hmm. I understand.
Use more solar panels and things like that.
Yeah, it's not always the most efficient, but sometimes maybe it's always been done this way. Mm-hmm.
What about planting trees and things like that?
Oh, that's a huge one. I mean, that's a real worldwide issue too. You know, as most of you have heard, the rainforests are disappearing, cutting down trees to grow feed for animals to feed us who love to eat meat. Mm-hmm. And that's a big issue. And even here in Southborough, I mean, we do pretty well. I think we have a lot of trees. Do you think we could do with some more?
What people don't understand is that animals, people and animals, breathe in oxygen and breathe out carbon dioxide. And the trees, on the other hand, and plants take the carbon dioxide and turn it into oxygen. So there's the cycle, and more trees, more plants are taking the CO2 and turning it back into oxygen, which is one way of getting rid of some of our CO2. But if we cut all the forests down, that's just compounding the issue.
Right. So that's a very important point.
Mm-hmm.
There was one other thing that we can also do, which is the building, to have builders be much more careful of how they build and the kind of properties they put up, as you mentioned, solar panels, and just generally build more efficient homes.
So we use less fossil fuel,
right,
which puts less CO2 into the air.
Right.
Mm-hmm.
So lots to think about.
Certainly is. That was very interesting and
was.
enlightening. So Sue, what's going to happen next month? Who's our guest?
So next month is going to be very interesting and very relevant, I think, to this time of year that we're coming into spring now. We have Dr. Andrew Vince, the state ornithologist, who's coming to us from Mass Fish and Wildlife in Westborough. And he is going to be talking about the birding population and what's going on in our own backyards, the nesting situation at this time of year when they're all busy. There'll be an opportunity for people to ask all kinds of questions about the birds that they see, and perhaps birds that we'd like to see in our neighbourhoods that we're not seeing anymore.
I saw 5 bluebirds at my bird feeder.
Did you really?
5 of them. And I saw them one time and I never saw them again. So
well,
I don't know.
That's unusual because normally they establish their territory and they're there every day. Yeah. And what a treat to have bluebirds.
And 5 of them. That was interesting.
I'm lucky enough to have them at my feeder too. Mm-hmm. And the way I got them there was putting out suet that has the berries and seeds in it. Mm-hmm. And they've been coming all season.
Really?
And I just can't believe it. Every day.
Try that.
So it's the suet that they come for. So I suggest you might want to, especially if they came.
I have suet out there, but it attracts the other birds, but it hasn't.
I wonder if it's the berries and the seeds that's in the suet.
Maybe I should try that. Yeah.
Okay. But these are questions that you'll be able to ask Dr. Vince when he comes. So
great.
It's going to be a great opportunity for everybody to educate themselves a little more about what's going on in the backyard.
Oh, great. So, all you people out there, stop by the Senior Center and register to come to our breakfast club next month. And in fact, while you're at the Senior Center, take a look around and see all the activities that are going on there. The Tai Chi, the card playing, the pool playing, songsters, chorus, and so on and so forth. There's a ton of things going on here at the Senior Center. There's also the professional help you can get from Cindy Beard, who is outreach, and our nurse, Leslie Chamberlain, who can answer any of your health problems. So it's a great place to come and stop by, register for our breakfast club next month. And
One other thing, don't forget, I want everyone to know that all the presenters who have been helping us out through this series, this is our second year now, they all donate their time free of charge, and we're very grateful to them. I mean, they bring a lot of expertise and tremendous professional background, so we're very fortunate. Everybody here donates their time. The folks filming this even, you know, this is all done to make it a little bit more special for you. So support us and come and watch. We'd love to see you.
so there's a lot going on behind the white picket fence here on Carterville Road. And Carterville Hall is a friendly place, and the latch string is always out.
And I know, who knows what the latch string is, because I don't. I hadn't heard that term before, and Bill brought it up to me, so maybe he'll explain.
And the latch string is a string that's on your door that pulls the latch up to let people in. If you're on the outside, the latch string comes through the door and it's hanging out there. So if your place is welcoming and you want people to come in, you put the latch string through the door so they can pull the string and open the latch and walk in. And certainly that's what we want you to do when you come to Carterville Hall, the senior center here in Southborough. So have a good day, Sue, and see you next month at the Breakfast Club.
Yeah, see you then, Bill. And why don't you join us?